So we can use this infinite the sum of an infinite geometric series to do this next problem where we have a repeating decimal 0.777777, right? And we know that a repeating decimal is a rational number, and all rational numbers can be written as a fraction. P over Q, where I don't think they usually use P and Q, but where P over Q, where P and Q are integers. Okay, so how do you do that? Well, think of this 0.7777 and it's repeating, right? Well, that's equal to 0.7 plus 0.07 plus 0.007 plus, and then on it goes, right? Now, if you change those to fractions, that's 7/10 plus 7 hundredths plus 7 thousandths, and on it goes, right? It's infinite. All right, so that's your infinite geometric series right there. What's the ratio? Well, if you look at it, you're multiplying by 1/10 each time. So R is 1 over 10. So if you think about that, hopefully that'll make some sense to you. Okay, so we've got our R. Now let's pull out our sum. It's a sub 1 over 1 minus R. So for us, that's going to be a sub 1 is 7/10 over 1 minus 1/10, which is going to be 7/10 over 9/10. And then if you keep change flip, 7/10 times 10 over 9, which the 10s cancel, you get 7 over 9. Now, if you put that in your calculator, 7 divided by 9, it should show 0.77777. 7 divided by 9, and there it is. Now mine just rounds it off at the end. But yeah, that's the actual rational number for 0.77777. Okay, so at the beginning of this week, I put in kind of a funny little text message about the guy trying to figure out where the cake went, you know, the 0.0001 of the cake. Well, what he was doing, he was using 0.33 for the third of the cake, right? But really, it's 0.333, and it keeps going, right? And if you have 3 of those, and you're adding those up, what are you going to get? You're adding those up, you get 0.999, and it's repeating, right? So how do you figure out that sequence then, or that sum of the infinite geometric series? You can do the same thing we were just doing a minute ago. You'd have 9/10 plus 9 hundredths plus 9 thousandths, you know, just like we did with the 7. But now you're going to have 9/10 over 1 minus 1/10. Well, that's going to be 9/10 over 9/10, which sure enough, that's going to equal 1, the whole cake, right? Okay, so that's a better, more mathematical answer than the one they gave in the text message. Okay, so the sum is 1, you get the whole cake.